Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do another code review. And the code review that I'm going to do this morning is going to be quantile regression versus linear regression on the geyser dataset. But before we do that, what we need to do is we need to find out what quantile regression is. So we're going to use sklearn's quantile regression. So we're going to look and see what sklearn has to say about it. So it's a linear regression model that predicts conditional quantiles. The linear quantile regressor optimizes the pinball loss for a desired quantile and is robust to outliers. This model uses L1 regularization like lasso, and then you can read more on the user guide. And then when you get into the user guide, it will take you to quantile regression, and it gives you the formula for quantile regression, and it also gives you some diagrams. And there is actually, for quantile regression, I think there is actually a program in sklearn that allows you to check out quantile regression as well on top of that. So you can read that on your own. I just wanted to bring that to your attention and highlight that for you. So if you want to know what quantile regression is, you can read it. So it's a type of linear regression. So what we're going to do is we're going to check to see which type of regressor works best. Is it going to be quantile regression or linear regression? So the first thing we're going to do is we're going to create our program in Google Colab, which is a free online Jupyter notebook hosted by Google. And Google Colab is a great platform to use, with the exception that it doesn't have an adequate undo function. So what that means is that you need to be careful not to accidentally overwrite or delete any code, and I've done that before, so you need to be careful not to do that. So after we have created our Jupyter notebook, what we're going to do is we're going to import the libraries that we're going to be using in the program. So we're going to import pandas as PD, and what that does is that creates your data frames and it processes the data. We're going to import NumPy as NP, and so what that does is that creates your NumPy arrays and it performs numerical computations. We're inside the program, we're going to import sklearn, and what sklearn does is provide machine learning functionality. We're going to import matplotlib.pyplot.plt as PLT, and what that does is that visualizes the data, and then we're going to import Seaborn as SNS, and what that does is that statistically visualizes the data, but it also has a few data sets that you can use, and we're going to use data sets from Seaborn as well. So we're going to look at the data sets. These are the data sets that come with Seaborn that you can use in your experimentation. And in this particular example, we're going to use the geyser data set. So data equals SNS dot load data set geyser cache equals true, data equals data dot iloc, all of the rows and the first two columns. And there you go. So that's your data set, because we didn't want the last column. We could have had the last column if we wanted to. If we wanted it to be a classification model, we could have used the last column, but I didn't want it to be a classification model. I wanted it to be a regression model. We check to see what information we have in the columns. So the duration column is a float and the weighting column is an integer. We check to see if we have any null values. There are no null values. We check our statistics using the describe function, and you can see the statistics of the data set. And now what we're going to do is we're going to plot the data set on a scatter plot. And so you can see that the higher the waiting time, the greater the duration. So it shows you that in this scatter plot, where you can see the higher the waiting time, the greater the duration. Now we define our x and our y variables. So y is data duration, x is data waiting, and then we analyze y. So that's the histogram that is made when we analyze our y variable. Now what we're going to do is we're going to use sklearn to split the data set using the train test split method. So xtrain xval, ytrain yval equals train test split, xy test size equals 0.1, random state equals 42. So you've got xtrain equals xtrain.values.reshape -1, 1. Xval equals xval.values.reshape -1, -1. And then we check the shape of the xtrain and the xval because it's supposed to be a data frame. Now we go to linear regression. And so this is the model that we're going to be using. And with linear regression, that's a sklearn model. Model equals linear regression dot fit xtrain ytrain, and the score is 82%. We make predictions on the model, that's ypred, and we're going to predict on the validation set, and the score is 49%, so that doesn't look great. Now we check our mean squared error, and your mean squared error is 0.53. And we put the actual values versus the predicted values on a chart, and you can see that you can see the actual values are the blue dots and the predicted values is the line. And so you can see that they're spread out, they're not really close. And then so we create a data frame of the actual values against the predicted values. Now what we're going to do is we're going to do quantile regression. And with quantile regression, we're going to have a quantile of 0.5. You can set the quantile of anything you like, but we're going to do a 0.5. And so we get an 81% accuracy on that. Let's see what we had on linear regression. We had 82% accuracy on linear regression. We predict on the model with ypred. We have 51% when we predict on the model. Let's see what we had on linear regression. We had a 49% when we predicted on the model. And now we check our RMS. That's your root mean squared error. We have a 0.52 root mean squared error. And we have a 0.53 root mean squared error on linear regression. And so what we do is we plot the actual values against the predicted values, and you can see how the actual values are spread out on the graph. And then we create a data frame where you can see the actual values and the predicted values. And the thing that you need to keep in mind in this particular instance is the quantile regression performed just slightly better than the linear regression. So it's always worth trying quantile regression to see if that will give you a better RMS, a better error, and you select the Quantile for anything that you like, and you can study up on the internet for Quantile regression, and it'll give you lots of exercises to do. But I just wanted to show you how to do it on sklearn. So, because if you have a machine learning model, what you're going to want to do is make predictions. But I've got this one over here that's on stats models. But stats models makes a lot of nice little diagrams. Like this is a nice diagram. But it doesn't really give you the predictions per se, although it gives you a lot of nice diagrams. So what we wanted to see was actually the predictions. So I'm going to go ahead and close this video because we've covered everything that we want to cover with Quantile regression. We've covered Quantile regression on sklearn. We've made a program with linear regression and Quantile regression so you can see how to do it. And yeah, we've talked about it. And so what I would like to do is I'd like to go ahead and close this video. So I'd like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more videos for you in the future.